Good morning everyone, this is Sotota Sahu lecturing in Chemical Engineering UJ Raulkela. Today we are going to discuss about the topic unit and dimension which is studied in 3rd sem Chemical Engineering Stoichiometry. Hello everyone, now we are going to discuss about unit and dimension. First, what do you mean by unit? An unit is an arbitrarily selected standard for measurement of a physical quantity. For example, if we have to measure volume, so it can be measured in cubic meter, liter, etc. Like if we are going to measure length, we can measure in centimeter, meter, foot, etc. Now let's come to the second point. Any physical quantity that can be measured or counted is always expressed as the product of numerical value and unit. This means any physical quantity is measured by multiplying a numerical value and the unit. For example, the distance between the two stations is 100 meter, where 100 is the numerical value and meter is the unit. Now let's come to the classification of physical quantity. There are two types of quantity. One is the fundamental or basic quantities and another is the derived quantities. In fundamental quantity, they are length, mass, time, temperature, etc. Whereas derived quantities are obtained from the basic quantities. They are area, velocity, acceleration, etc. Now, let's come to the classification of units. There are three types of units. One is the base unit, another is the derived unit, and third is the multiple units. The base units, these are the units for measuring the basic quantities. For length, it's centimeter or meter. For mass, it's kg or gram. For time, it's second. The derived units are the units that are obtained by multiplying or dividing the base units such as centimeter square, meter per second, etc. Multiple units are the units that are obtained from the multiple or fraction of the base unit such as hour, minute, second, etc. Now let's come to the unit systems. There are four types of system of unit. One is the SI, another is the MKS, another is CGS, and the fourth one is FPS. For length, the unit each for SI it's meter, for MKS it's meter, for CGS it's centimeter, for FPS it's foot, and the dimension of length is L. Whereas for mass, the unit for SI and MKS is kg, whereas for CGS is gram and FPS is pound, and the dimension is m. Similarly for time, all the units are second, and the dimension is theta. For temperature, the SI unit is Kelvin, MKS unit degree Celsius, CGS unit is degree Celsius, and FPS unit is degree Fahrenheit, and the dimension is capital T. Now, let's come to the fundamental quantities and their units. There are 7 types of fundamental quantities. They are mass, length, time, temperature, current, amount of substance, luminous intensity. The symbol for them are, for mass it's m and the unit is kilogram. For length it's L and the unit is meter. For time it is small t and its unit is second. For current it is capital I and the unit is ampere. For temperature it is capital T and the unit is Kelvin. For amount of substance the unit is mole and the symbol is small n. For luminous intensity its symbol is small l subscript v and the unit is candela. Now let's come to the derived quantities and units. The derived quantities are expressed in terms of the derived unit, and the derived unit are obtained from fundamental units. For example, volume is the product of three lengths. Okay. Now the unit of length is meter. So the unit of volume will be meter cube. Similarly, pressure is expressed as force per unit area. The unit of force is Newton and the unit of area is meter square. So the unit of pressure will be Newton per meter square. This table represents the units for different derived quantities. Let's come to the first, the volumetric flow rate. Volumetric flow rate means volume per time. So unit of volume will be meter cube, and for time it's hour or second. So it will be meter cube per hour or centimeter cube per second. Similarly for volume, the unit will be meter cube or liter. For density, the formula is weight divided by volume. The unit of weight is kg and the volume is meter cube. So kg by meter cube or gram by centimeter cube. Similarly for force, it is Newton, dyne or kilogram force. Now let's come to the conversion of factor to SI units. Means how we convert one unit to another unit. For example, in length, you have to convert centimeter to meter. How we are going to convert? We know 100 centimeter equal to 1 meter. So 1 centimeter will be equal to how much? 1 divided by 100 meter. That will be equal to 0.01 meter. So 1 centimeter will be 0.01 meter. Similarly, in order to convert 1 inch to meter, we have to multiply 0.0254. In area, in order to convert 1 centimeter square to meter square, we have to multiply 10 to the power minus 4. In volumetric flow rate, in order to convert 1 liter per second to 1 meter cube per second, we have to multiply 10 to the power minus 3. Similarly, in force, 1 Newton equal to 10 to the power 5 dyne. So 1 dyne will be equal to how much? 1 divided by 10 to the power 5 Newton. So that is equal to 10 to the power minus 5 Newton. So in mass, 1 kg equal to 1000 gram. So 1 gram will be equal to 1 divided by 1000 kg. That is equal to 10 to the power minus 3. In pressure, 1 atmosphere equal to 1.01325 into 10 to the power 5 Pascal. 1 atmosphere equal to 760 mm, and that is equal to 1 bar.